Now let's prove the trigonometric identity of cot square A plus 1 equals cosecant square A. Consider a triangle ABC, right angled B. By applying Pythagoras theorem, we have AB whole square plus BC whole square equals AC whole square. Make it as equation 1. Dividing each term of equation 1, that is, AB whole square plus BC whole square equals AC whole square, by BC square. We get AB whole square by BC whole square plus BC whole square by BC whole square equals AC whole square by BC whole square. This implies that AB by BC whole square plus BC by BC whole square equals AC by BC whole square. On simplification we get AB by BC whole square plus 1 square equals AC by BC whole square. Make it as equation 2. By observing from the right angle triangle ABC, we get AB by BC equals cot A, since cot A equals adjacent side by opposite side. Similarly from figure we get AC by BC equals cosecant A, since cosecant A equals hypotenuse by opposite side. Substituting AC by BC equals cosecant A, and AB by BC equals cot A in equation 2, that is, AB by BC square plus 1 square equals AC by BC square. We have cot A square plus 1 square equals cosecant A square. Therefore cot square A plus 1 equals cosecant square A. The above identity is true for all A such that 0 degrees less than A is less than or equal to 90 degrees. Hence this is said to be a trigonometric identity. Note, as cot A and cosecant A are not defined for A equals 0 degrees, A is taken as greater than 0 degrees. Let's summarize the three basic trigonometric identities. Cos square A plus sin square A equals 1. 1 plus tan square A equals secant square A. Cot square A plus 1 equals cosecant square A. Let's now see how to express each trigonometric ratios in terms of the other trigonometric ratios. We can now find the values of other trigonometric ratios using the basic trigonometric identities, as each trigonometric ratio can be expressed in terms of the other trigonometric ratios. And also we can find the other trigonometric ratios when any one of the ratio is given. Let's see how to find the trigonometric ratios using the basic identities. Example 1. Suppose we know that tan A equals 1, and we need to find the other trigonometric ratios, values. Solution, given that tan A equals 1. We know that secant square A equals 1 plus tan square A. Therefore substitute tan A equals 1 in the above identity, we get secant square A equals 1 plus 1 square. Secant square A equals 1 plus 1. Secant square A equals 2. Applying square roots on both sides, we get secant A equals root 2. As we got the value of secant A, now let's find cos A. As we know that secant A equals 1 by cos A. Therefore cos A equals 1 by root 2, since secant A equals root 2. As we know cos A equals 1 by root 2. Now let's us find sin A using the identity. That is, cos square A plus sin square A equals 1. Substituting cos A value in the above identity we get 1 by root 2 whole square plus sin square A equals 1. This implies that 1 by 2 plus sin square A equals 1. This implies that sin square A equals 1 minus 1 by 2. This implies that sin square A equals 1 by 2. Applying square roots on both sides, we get sin A equals 1 by root 2. We know that cosecant A equals 1 by sin A, then cosecant A equals 1 by root 2 equals root 2. Therefore cosecant A equals root 2. As we know that cot A equals 1 by tan A. Therefore cot A equals 1, since it is given that tan A equals 1. Example 2, to determine the values of other trigonometric ratios using identities. If tan A equals 1 by root 3. Solution, given that tan A equals 1 by root 3. As we know that cot A equals 1 by tan A, we get cot A equals 1 by root 3. This is equal to root 3. Therefore cot A equals root 3. Let us now find the value of secant A using the identity secant square A equals 1 plus tan square A. Substituting tan A equals 1 by root 3 in the identity, we get secant square A equals 1 plus 1 by root 3 whole square. This implies that secant square A equals 1 plus 1 by 3. Taking LCM as 3, we get secant square A equals 3 plus 1 by 3. This implies that secant square A equals 4 by 3. Applying square roots on both sides, we get secant A equals 2 by root 3. And we know that cos A equals 1 by secant A, we get cos A equals 1 by 2 by root 3, since secant A equals 2 by root 3. This implies that cos A equals root 3 by 2. Therefore cos A equals root 3 by 2. As we know that cos A equals root 3 by 2. Using the identity that is cos square A plus sin square A equals 1, we can write sin square A equals 1 minus cos square A. This implies that sin A equals square root of 1 minus cos square A. Substitute cos A value in the above equation, we get sin A equals square root of 1 minus root 3 by 2 whole square. This implies that sin A equals square root of 1 minus 3 by 4. Taking 4 as LCM, we get sin A equals root 4 minus 3 by 4. This implies that sin A equals root 1 by 4. Therefore sin A equals 1 by 2. As we know that cosecant A equals 1 by sin A, we get cosecant A equals 1 by 2. Therefore cosecant A equals 2.